Hello everyone, in this video we're going to explore the topic 5.8, 5.9 part B, reconstruct the function f from the function f prime. Now in order to do that you need to understand the following. If f prime of s greater than 0, then the function f of s is increasing, right? It's going to be like this. If f prime of s less than 0, the function f of s is decreasing, right? Now, if f prime of s changes from negative to positive, right? Negative, which means going down, positive going up, right? So right here you have the relative minimum, right? If f prime of s changes from positive to negative, right? Which means going up and then going down, you have the relative maximum right here, right? Now, f prime of s is increasing, then f of s is concave upward. Because if f prime of s is increasing, f double prime of s must be greater than 0. The function f of s is concave up, right? Now, similarly, f prime of s is decreasing, which means f double prime of s less than 0, right? It tells us that f of s is concave backward, right? F prime of s has an extremum. Then f of s has a point of inflection, right? Look at this one right here. Relative maximum, relative minimum of the function f prime of s. These two guys become the point of inflection right here, right? Now the 0 of f prime of s, 1, 2, 3, become the minimum, maximum, and minimum, right? How do we know which one is the minimum, which one is the maximum? We look at this one right here, and this guy right here. Alright, if f prime of s changes from negative to positive, right? Look at this one right here. This guy below the x-axis, right? Of the function f prime of s, so it could be negative, right? And then this guy above the axis is going to be positive, right? So it changed from negative to positive, right? Which means it's going down first and going up like this. So this is minimum, right? Similarly, this guy right here above the axis, so it could be positive. This guy right here below the axis, so it could be negative, right? So the side change from positive to negative, which means going up first, going down. This is maximum, right? So this guy becomes maximum, right? And the last one right here, this guy below the axis, so it could be negative. This guy above the axis, it's going to be positive, right? So it changes from negative to positive. It's going to be like this, right? So it could be minimum. We need to draw the tangent line. And we see that the tangent line is going up, which means the slope of the tangent line is positive. But the slope of the tangent line of f prime of s is f double prime of s, right? So which means f double prime of s is positive. And this guy positive, the function is concave up, right? Similarly, you just draw the tangent line right here, right? You see that the slope of this tangent line is negative, right? Which means f double prime of s less than 0. The function is concave downward, right? And the last one, this one is concave upward, right? Right here. Now let's look at example number 9. Given f prime of s, we need to sketch f of s, right? Now f prime of s is right here. This guy, right? This is straight line y equals 2, right? It tells us that this one is the slope of the function f of s, right? The slope of the function f of s is 2, right? So we just find the slope right here and we connect it. So this one is the function of f of s, right? It's actually the linear function. Now we just make up an example, right? So y equals 2s plus 2 or something like that. If we take the derivative of this one, it turns out to be 2, right? So it's going to be 2 right here. You see that? You can do backwards, you will see it. Now, what if f prime of s is right here? Does that mean f prime of s is 0 everywhere, right? Then when you set the function f of s, it's going to be either like this, or like this, right? Because when you take the derivative of this one, for example, I have y equals 4. This is y equals negative 4. This is y equals 0. When you take the derivative of this guy, it's going to be 0. Y prime equals 0, right? So, since f prime is 0 everywhere, the slope of f is 0 everywhere. So, f must be a constant. Below are the possible graph of f of s, right? We have three different cases: positive constant, 0, or negative constant, right? Now let's move on to question B. The function f prime of s is a linear function, right? Then the possible f of s must be a quadratic function, right? Now we need to locate the 0 right here, right? The 0 of f prime of s becomes the minimum or maximum of f of s, right? Now we need to look at this one right here, this guy below the axis, right? So it's going to be less than 0, right? F prime of s less than 0. It tells us that the function f of s is decreasing, right? So it could be like this, right? And this guy right here is above the axis, right? It tells us that f prime of s is greater than 0. Then the function f of s must be increasing, right? So it could be like this. Then this guy right here becomes the minimum of f of s, right? Now let's move on to question C. Alright, so we observe that the function f prime of s always below the axis, right? It tells us that f prime of s always less than 0 or equal to 0, right? On the interval negative infinity to positive infinity, right? And then it tells us that the function f of s always decreasing, right? Now we need to locate this one. This one is the maximum of the f prime of s. It becomes the point of inflection of the function f of s, right? So it could be right here. Now again, look at this one. This one is parabola, which means quadratic, right? When you scale the function f of s, it's actually the cubic function, right? Now this one in the interval negative infinity to 0. As the program of s is positive, right? You just draw the tangent line, right? And the slope is positive. It tells us that f the program of s is positive, right? If this one positive, it tells us that the function f of s from negative infinity to 0 is concave upward, right? So it's gonna be something like this. And on the right side, you just draw the tangent line and you see that f the program of s is less than 0, right? The slope of this one is negative, right? And then f of s must be concave downward, right? So it could be like this. Now let's move on to question D. First, we need to locate the 0 of the function f prime of s, right? So we have negative 4, negative 2, and 4, right? So this 0 becomes the relative extrema of the function f of s, right? So we know that the function f of s must pass the point negative 4 and 2, right? So I'm going to locate the negative 4 and 2, the point right here, right? That's the first point. Alright, and we know that from negative infinity to negative 4, the function f prime of s is less than 0, right? So because this is below the axis, right? So the function f of s should be decreasing, right? And this guy right here actually the relative minimum because f prime of s changes sign from negative to positive right here, right? So you know that negative to positive is going to be relative minimum, right? So it could be decreasing like this. Alright, now next one. From negative 4 to negative 3. F prime of s is above the x-axis, so it could be increasing, right? So this guy going up, right? Now keep in mind, right at negative 3, this guy is the relative extrema of f prime of s. Then it becomes the point of inflection of the function f of s, right? From here, you just draw the tangent line. You see that the slope of the tangent line of f prime of s is positive, which means at the program of s right here is positive. The function is concave up. Similarly, this one at the program of s is negative. The function is concave down, right? So the point of inflection right at negative 3, so concave up and concave down is be something like this. Alright, now next one right at negative 2. F prime of s is above the axis from here to here. Do you see that? And then below the axis from here to here. So it changes sign from positive to negative. Positive to negative is going to be maximum here, right? So right here is going to be maximum here, right? So it's going down like this, right? Next one we have one right here. This one is the relative minimum of f prime of s. This guy becomes the point of inflection of f of s, right? So right here it should have the point of inflection right here. And right at over here, this one changes sign from negative to positive. Negative to positive is actually the minimum, right? So it's gonna be something like this, right? Right at 4 right here, this one is the minimum. Then from 4 to positive infinity, the function f prime of s is above the axis. So the function f of s is to be increasing, right? So to be like this. So finally, we're going to check our work. The relative minimum right here, relative minimum right here, relative maximum. The point of inflection is here, right? Point of inflection is here. Now we check our work. Point of inflection is 1 and negative 3, which is correct, right? The 0 right here become the relative extrema, right? Minimum, maximum, and minimum, right? Now let's move on to question E. We need to locate the relative extrema and point of inflection, right? So we see that the 0 of f prime of s right here becomes the relative extrema of the function f of s, right? So it could be somewhere right here or right here, right? Depend. Now you have the relative extrema right here and relative extrema right here. These two guys right here becomes the point of inflection, right? So negative 3 should be somewhere right here and 1 should be somewhere right here. Now observe that the function f prime of s is below the axis from negative infinity to negative 5, right? So from negative infinity to negative 5, the function f of s is decreasing, right? So it could be something like this. X equal negative 5, the function obtains the relative minimum, right? Because it changes sign from negative to positive, right? Negative to positive is to be minimum. Alright, so it's going up right here, right? From negative 5 to negative 3, f prime of s is above the axis, so it could be increasing, right? From negative 3 to negative 1, right here, f prime of s above the axis, so it keep increasing, right? But if you draw the f the program of s, right, it's going to be negative. It tells us that the function f of s is concave downward, right? So it's going to be like this. And you have the point of inflection is at negative 3, right? The minimum value is at s equal negative 5, right? From negative 1 to 1, you draw the tangent line. You see that at the program of s less than 0, right? So it will be concave downward, right? So it's going to be something like this. Now, right at 1, this one is the point of inflection, right? From 1 to positive infinitive, at the program of s is positive, the function concave upward, right? So it could be something like this. Alright, so finally, you have the point of inflection is right here and right here, right? Negative 3 and 1. The relative minimum is at s equal negative 5, right? And the function f of s is decreasing from negative infinity to negative 5, right? Increasing from negative 5 all the way to positive infinity, right? Now observe that the function f of s is concave upward from negative infinity to negative 3, right? We look at this one, negative infinity to negative 3. F the program of s is positive, right? And from 1 to positive infinity, right? Look at this one, F the program of s is positive, right? And concave downward from negative 3 all the way to 1, right? So this one right here, concave downward. Now let's move on to question F. You see that the 0, negative 1, right? And the function f prime of s changes sign from negative to positive, right? Because this section right here below the axis so it could be negative, and this section right here above the axis so it could be positive, right? So when it changes sign from negative to positive, which means the function f of s decreasing and increasing, right? And this one is should be relative minimum, right? So at s equal negative 1 is to be relative minimum right here, right? Now, from negative infinity to negative 1 right here, f prime of s is negative, the function f of s is decreasing, so it's going to be something like this. From negative 1 to positive infinity, the function f prime of s above the axis, so it's going to be positive, right? The function f of s is increasing, right? And observe that if you draw the tangent line right here, so does that mean f the program of s positive, right? Similarly, you're going to draw the tangent line right here, f the program of s still positive, right? Which means the function f of s is concave up on negative infinity to positive infinity, right? Now let's move on to question G. First, we need to locate the 0 of f prime of s, so it's going to be negative 4 and 3, right? And the function f prime of s changes sign from negative to positive, right? Because it's below the axis right here and this one above the axis, right? So negative, positive. And then this guy right here from positive to negative, right? So this guy becomes the relative minimum, this guy becomes the relative maximum, right? So max as 3 and minimum as negative 4, right? So negative 4 right here, this one minimum and this one is maximum, right? So it could be something like this, right? Now, from negative infinity to negative 4, the function f of s is decreasing because f prime of s below the axis is going to be negative, right? So this guy decreasing. Alright. And then from 3 to positive infinity, it's going to be decreasing, right? So it could be something like this. Now from negative 4 to 3, f prime of s above the axis, so it could be greater than 0, right? So f of s should be increasing, right? And then the point of inflection is right here because this is relative estimate of the function f prime of s, right? So we have the point of inflection at s equal 1, right? So I need to lower down this one, negative 4, the minimum should be somewhere right here, right? from negative infinity to 1. The function f(x) is concave upward because if you draw the tangent line, you see that f the program of s always positive, right? So this guy should be concave upward from negative infinity to 1. So it could be something like this, right? And then from 1 all the way to positive infinity, the slope of the tangent line right here should be negative, right? So the function f(x) should be concave downward, right? It could be something like this. The minimum value is right here. The maximum is here. The point of inflection is here. The function increasing from negative 4 to 3, right? So negative 4 to 3. The function is decreasing from negative infinity to negative 4 and 3 to positive infinity, right? Now let's move on to question H. At x were 1, this one is the 0 of f prime of x, and it becomes the relative extrema of the function f of x, right? And we see that the function f prime of x changes sign from positive to negative, right? So positive to negative. This one is the relative maximum of the function f of x, right? So at x equals 1 is the relative maximum right here. Now, f prime of x is positive from negative infinity to 1, right? Which means the function f of x is increasing, right? So it could be something like this. And negative from 1 to positive infinity, right? So it could be decreasing. Now, we're going to check the second derivative, draw the tangent line. And we see that the slope of the tangent line is negative, which means f prime of x always less than 0. From negative infinity to positive infinity, it tells us that the function f of x always concave downward on the entire domain, right? And there is no point of inflection, right? Now let's move on to question I. The function f prime of x has 2, 0 right here. This guy becomes extrema of the function f of x, right? Observe that this guy is positive because it's above the axis, and this guy is negative because it's below the axis, right? The function is increasing and decreasing. So this one is maximum, right? So at 1, the function obtains the maximum value, right? And similarly, at 3, this one is negative, this one is positive, right? So this one is positive, it's going up, this guy is minimum, right? So minimum is 3 right here. Now, you see that the function f prime of s has the vertical asymptote, which means f of s is not differentiable on this point, right? So right here I just draw the vertical asymptote as s equal 2, which means the function f of s is not defined as s equal 2, right? Now, since this one is above the axis, which means f prime of s is positive, it tells us that the function f of s is increasing, right? From negative infinity to 1, right? So negative infinity to 1, so it could be like this, right? And decreasing from 1 to 2, right? So from 1 to 2, it's going to be decreasing, so it could be like this, right? So this one is the maximum. Now, you just draw the tangent line right here. And you see that the slope of the tangent line is negative. It tells us that f the program of s is negative. So f of s is concave downward, right? Alright, now similarly, from negative 2 to 3, the function f prime of s is below the axis, right? So it tells us that the function f of s is decreasing on this interval, right? So it's gonna be something like this. And from 3 to positive infinity, the function f prime of s is above the axis. It tells us that f prime of s is greater than 0. Then the function f of s is increasing on this interval. So it could be something like this, right? And observe that this one is the relative minimum, right? Now you just draw the tangent line, you will see that the slope of the tangent line always positive, right? It tells us that f the program of s greater than 0, then the function f of s is concave upward, right? Like this. Now let's move on to question J. We know that f prime of s is greater than 0 from negative infinity to positive infinity, right? It said s were negative 2. And then the function f of s is increasing on the real number, right? Now, f the program of s is less than 0 from negative infinity to negative 2. It tells us that the function f of s is concave downward on this interval, right? Similarly, the function f of s is concave upward from negative 2 to positive infinity, right? Because f the program of s is positive, right? Now f of s has no relative maximum nor minimum, right? Because this one is positive, this one is still positive, it's all above the axis, right? But f of s has a point of inflection s equals negative 2 because this one is concave downward, right? And this one is concave upward, so it could be like this, right? So we have the point of inflection s equals negative 2, so it could be somewhere over here, right? Now from negative infinity to negative 2, the function f prime of s is above the axis, so the function f of s should be increasing, right? So it could be something like this. And from negative 2 to positive infinity, it's still increasing, right? So it could be like this. Now let's move on to example number 10. Sketch a possible f of s with the following characteristic. Alright, question A. F prime of s greater than 0. This one tells us that the function f of s is increasing, right? For all s, so it's going to be on the entire domain, right? F the program of s greater than 0 tells us that the function f of s is concave upward, right? Now f1 equals negative 2, so s equals 1, y equals negative 2 is going to be right here, right? Function f of s should be something like this. F prime of s greater than 0 for s greater than 1. It tells us that the function f of s is increasing on the interval 1 to infinity. And f prime of s less than 0 for s less than 1. It tells us that the function f of s is decreasing on the interval negative infinity to 1, right? Now f prime of 1 equals 0. This one is the 0 of the function f prime of s. This guy becomes the relative extrema of the function f of s, right? Now f the program of s greater than 0 for all s. It tells us that the function f of s always concave up, right? And f of 1 equals negative 1, right? F of 1 equals negative 1 is going to be right here, right? So f prime of s greater than 0 for s greater than 1. So it's going to be something like this. Alright, f prime of s less than 0 for s less than 1. It's going to be something like this, right? F prime of 1 equals 0. So this guy becomes the relative minimum, right? Because the function f of s always concave up, right? Now question C. F prime of s greater than 0 for s greater than 2 tells us that the function f of s is increasing on this interval, right? And f prime of s equals 0 for s less than equal to 2. It tells us that the function f(x) will be a constant on this interval, right? And f the program s greater than 0 for s greater than 2. The function is always concave on this interval, right? And f of 2 equals 1. F of 2 equals 1, so keep it right here. Right? And this could be something like this. This one should be a straight line. And this one should be a curve. Alright, let's move on to question D. F prime of s greater than 0 for s greater than negative 1. So the function f of s should be increasing on this interval, right? And f prime of s less than 0 for s less than negative 1. The function f should be decreasing on this interval, right? Now, this is important. F the program of s less than 0 for all s different from negative 1. So this guy tells us that the function f of s always concave there, right? And f of negative 1 equals negative 2. So it could be something like this. Now let's move on to question E. First, we need to locate the relative extrema, right? So the 0 of the function f prime of s become the relative extrema, right? Now we have negative 3 and 1, right? So we need to look at this one here, f prime of s greater than 0 when s less than negative 3, right? So it could be positive right here and less than 0 from negative 3 to 1. So this guy becomes maximum, right? So negative 3 should be somewhere right here, right? And 1 right here becomes the minimum, right? Because f prime of s greater than 0 for s greater than 1, right? So minimum should be somewhere right here. Now next one, f of 0 equals 0. So the function must pass the origin, right? Now we know that f the program of s less than 0 for s less than negative 1, right? So from here all the way to the left, the function f of s is concave backward, right? From here all the way to the right, the function f of s concave upward, right? So we just get a graph is something like this. So we see that from negative infinity to negative 1, right? The function f of s is concave backward. And from negative 1 to positive infinity, the function f of s is concave upward, right? And we have the relative maximum right here. Relative minimum is right here. The function f of s passes the origin, right? Now let's move on to the last question. Question F. F prime of s greater than 0 for s greater than 2. F prime of s equal negative 1/2 for s less than 2. F prime of 2 does not exist. F the prime of s less than 0 for s greater than 2, and f of 2 equals 0. So f of 2 equals 0, which means the function passes this guy, right? And we know that f prime of s equals negative 1/2 for s less than 2. It tells us that the function f of s should be a linear function on this interval, right? So it should be something like this, negative 1/2 s plus 2, something like that, right? For s less than 2. I'm going to locate the y-intercept, right? Y-intercept equals 2, right? So I'm going to go down by 1, go to the right by 2, right? So it could be something like this. This is a straight line, right? Now, f prime of s greater than 0 for s greater than 2. It tells us that the function f of s is increasing on this interval, right? And f prime of 2 does not exist. It tells us that the function f of s has a sharp turn right here, right? F the program of s less than 0 for s greater than 2. It tells us that within this interval, the function is concave backward, right? So it could be something like this. And it's your time to solve. Thank you for watching. I hope you enjoyed the video. Remember that if you fail to prepare, you're preparing to fail.
rise like tall buildings as the chemicals they take us higher. The night's young, it has just begun as she puts her hand in mine.